Unreal Engine can very much make 2D games. It's maybe not the best engine if you are looking for an engine to purely make 2D games in, but if you are interested in using Unreal Engine as a general engine and you don't want to learn something different to make something 2D, you very much can make 2D things in Unreal Engine. So let's make a handful of videos here to show how to get started with making 2D games in Unreal Engine. And the wonderful thing about Unreal is, since it is a more 3D oriented engine, you can very much do interesting things with this and make games that take advantage of a mix in art between 2D and 3D. Think about things like Octopath Traveler, which is a game that was made in Unreal Engine. That sort of style, a 2D character in a more 3D world, is exactly what this lends itself well for, but you can also make fully 2D games, side-scrollers, top-down games, whatever you want. We're going to go for a bit of a side-scroller type game in this series, but you can do whatever you want. So to get started, you want to go into Edit and make sure that Plugins is enabled, so that you can go to your Plugins tab, and then you're going to look for Paper, where you want to enable Paper 2D if it isn't already enabled. And then you might not have PaperZD yourself, because this is a marketplace plugin made by a community member. This is not entirely necessary, but it will help with some things like introducing animation graphs for your 2D animations, much like animation blueprints for your 3D animations usually, and animation notifies. This mostly is what I care about, to be honest with you, for your 2D flipbook animations. You can do without it, but it's good to enable it and get it, and especially if you're going to be downloading the project files from either the Patreon or as a YouTube member, do be aware that I have PaperZD enabled, and you probably should have it yourself. To get started, I have gotten a handful of sprite sets here for the tile sets and all that kind of stuff that we're going to be looking into in the future, and also a character sheet for a character. I'll leave the links to the download pages that I found these at in the link below as well, because I didn't make these myself. But let's open up our Forest Boy character here, because you will immediately notice that there's going to be one minor detail that is an issue. Well, actually two. Number one is I got a character sheet that is not transparent in the background, so that's going to be a bit of an issue. And number two is if I zoom in, these pixels get very blurry, because these are very, very low resolution pixel art images. So let's solve both of those issues. The first issue of the background we'll get to in a moment. The blurriness is very easy to fix though. We're going to go over here into the level of detail, into the texture group. At the moment it's set to world, because anything that you import as an image, it usually assumes that it's going to be a texture that you apply to like a 3D mesh, and those tend to look better when they are scaled up and down if they're a little bit blurry and not very like sharp and pixelated. But for pixel art, of course, we do want them to be sharp and pixelated. So we can just change this for texture group to 2D pixels, which is unfiltered, and suddenly it's nice and sharp pixel art. So that's issue number one fixed. Issue number two still is the green background. If we scroll down a little bit, in the adjustments, we can see the chroma key texture box, which we're going to set to true. And then the chroma key color, we get a color picker. We just can get this little eyedropper, and we can get the exact color from the background. Okay, and now the background is transparent, so we'll actually be able to use them as sprites without having a green box around our character. Now, if we go into all of our like background or detail stuff, our terrain, for instance, we have a bunch of separate images, and you don't want to go into every single one and do that texture group and then find pixel and so on and so forth. Luckily, these are already set to being transparent in the background, so that'll help us. We can just select all of them at the same time and go into Asset Actions, Edit Selection in Property Matrix, and that'll get us a table of all of the assets that we've just selected and their settings. So we can just type in Pixel 2D for all of them, save, and now you will see all of them are already instantly properly set to being Pixel 2D art. So you can do that for everything in your project fairly quickly and fairly easily. We'll get into like the whole tile map thing in a future video. For now, let's focus on our character sprites. Because we now have one single image with all those individual sprites in it, but we need to extract those sprites to actually create sprite assets out of them. Because things like our flipbook animations are going to require the individual frames that we have in this sprite sheet. So we can very easily just right-click any texture and go into sprite actions. If you just create a sprite, it's just going to take the entire image and create one single sprite out of it. So that's not exactly what we want to do. What we want to do instead is we want to extract these sprites from our sprite sheet. Now, usually it will do a pretty good job at automatically recognizing everything as individual sprites. In this case, it didn't, and that is slightly annoying, but it's also good to show you how to do it manually. So we can set this from auto to grid, and here I think the artist on the page said that these are 24 by 24 pixels. So you may need to mess around with this a little bit to get these to work. So I guess we'll do this live on the go here. We have the number of cells in the X and the Y direction. You might need to extract, in this case, the individual sprites from each row because they are offset weirdly. A good sprite sheet shouldn't have this annoyance going on. A good sprite sheet should ideally just be evenly spaced wherever possible. Sometimes a sprite may just require to be a little bit taller or a little bit longer. That happens. This sprite sheet is particularly quite disorganized in the way it's laid out, so that's not great. So let's extract these just one row at a time. We have the top row here, which has 5 sprites. So we get 5 cells, and we have 1 cell tool, and then we can start like dialing these back a little bit. The width clearly isn't 24 pixels. It's more like 16 pixels maybe. And then in the margins, we can start moving this thing as a whole around, just like the starting points of the origin of the top leftmost first sprite. So let's see if that's like 10, maybe 11, something like that. And then for the Y, we do the same, so up a little higher. There we go. Now we have everything sorted out. And this actually is pretty good spacing. We don't need them to be spaced out at all, but let's pretend like we do. Because the cell width can be slightly less, I think. We can make this like 14 pixels, and suddenly it's a good size for the sprites, but there's spacing in between, and that's where the spacing comes in. So we can say, well, we want 2 pixels of spacing in between each sprite. And there we go. We now have all of our sprites more or less properly like selected. Again, for most sprite sheets, it actually does do a pretty good job at automatically recognizing all the sprites, and you can just automatically do it. Sometimes you have to go through and do it manually. If you have your own artist, or you are your own artist, just be sure to lay out your sprites in a proper grid so that you can easily extract them if need be. For now, let's extract these sprites, and we have a handful of sprites to work with. So I'm going to make a folder here for the individual sprites. And you'll probably want to name these, because I think this will be like player idle 1, and then we'll get a player idle 2 and a player idle 3. And I think those are the only ones for the idle animation, because I think this might be a different animation. So with that, we want to do one last thing, and then I think I'm going to end off this introductory video for like sprite sheets and sprites and all that kind of stuff. And then next time we'll talk about tile maps, and we'll start building some levels with that. Let's make this into an actual animation, because how do animations work in PaperZD? Well, you can just right click and go to PaperZD here and make a paper flipbook. And a paper flipbook will contain keyframes. Let's just create a little bit more room for you to see that here. And we can start adding keyframes, and that will just make a flipbook animation. So we can say player idle 1, and then we can add another keyframe. It can be player idle 2. And another keyframe yet will be player idle 3. And now we have a simple idle animation. It's a little too fast though. And that's where either the frame run comes in, or the frames per second. So the frame run is how many frames does this image stick around for on screen before moving on to the next image. So if I set this first one to 5 frames, you can see that this frame sticks around a little bit longer, and then these two play very, very quickly. We don't necessarily want that in this case, maybe. We just want to slow down the animation as a whole. By default, flipbooks play at 15 frames per second. You can just put something else in here. So maybe at 5 frames per second, this looks a little bit more natural, right? So that'll be our idle animation. This is how you can set these up 1 frame at a time. You can do this slightly more smoothly by just selecting all of the images that go into your animation, right-click it as long as they're all sprites, and you can just create a flipbook like that. And that'll automatically create a flipbook with those frames. So you can always add more frames if you want to. And we can set the frame rate here to 5, and we're pretty much back where we started. We can also use this more interactive editor to increase the length of, or decrease the length of any of the individual frames here if we want to. I prefer using actual numbers, but if you prefer like this timeline approach, that is entirely a possibility that you can do as well. And now these are assets that we can just drag and drop into the world, and they are positively tiny because they are just like 16 pixels tall, so they are not particularly big. And this one is also now outlined to the middle of the sprite. So both of those are things that we don't really want. So I'll go into the property matrix editing for all of the sprites that I have gotten so far. So asset actions, property matrix. And what we're going to do is I'm going to set the pivot mode to being the bottom center. That will make, as you will see in a moment, the origin point of all the sprites be in the bottom center. So that way, if we scale them up, it scales from the bottom center, and the actual like world position of them will be calculated from their feet and not from the middle of the sprite, which in most cases is the more logical way to do things. You can also use the bottom left if you want to, in which case the bottom left corner of the sprite will be the anchor point, which might work a little bit better with aligning on certain like tile maps and that kind of stuff. We're just going to go for the bottom center. Then we also have the pixels per unit, and this is how it will be scaled up or scaled down. This is a little bit counterintuitive though, because it's not just a scale, it's actually like an inverse scale, meaning that the lower this number is, the bigger your sprites will be in the actual world. So if we set this to 0.1, that means that every pixel is going to be 10 times as large, which is pretty good for what we want. So now we can see we have it aligned to the bottom center, and it's a pretty big image overall. And even if we like play the game, we will be able to see he's just floating around. He is visible from 2 different sides because there's no backface culling on sprites that we place into the world. So that can be either nice or annoying depending on what you want to do. But as you can see, it's just a 2D sprite, just kind of chilling, just kind of existing in this 3D world. That's because we don't have a 2D world for him to inhabit yet. Next time, we're going to make tile maps and tile sets to fill the tile map with, and we'll start building a proper 2D world in a level that this guy can exist in without having an existential crisis about there being a 3rd dimension around him. Just imagine if you lived in a 4-dimensional world. That would be scary. So let's give this little guy a bit of a break. If you want to get the project files, either the finished project files with everything in it or just this episode's progress, there's a link down below in the description to the Patreon, or for YouTube members to download either or both of those project files. We're back with more Unreal 2D development. Last time we got started with setting up sprites and a sprite animation, and this time we're going to give this guy a world to live in. We're going to make a tile map for him to inhabit and just have some fun with all of that. So, as I showed in the last video, we have this grassland terrain tile set here. There's a link down below in the description. All of these are free assets that I'm using just for like educational purposes. But if we open this up, I think we still need to set this to be properly scaled because it's all kinds of blurry. So let's go into the texture group here and set this to 2D pixels so that it's all sharp and pixelized. And then instead of making a sprite out of this, which we don't want to do, what we're going to do instead is we're going to create a tile set. If we want to make a tile map, we first need a tile set to pick tiles from to populate a tile map with. We'll get into the tile map in a moment. First, create a tile set, and this will have a handful of settings to go with it. So you can just click anywhere on the screen and that will show you the tiles that you're picking. But these, of course, are not exactly the tiles that we want. So we want to set the tile size to the correct number, which in this case, I'm guessing is going to be 16 by 16. And it is, and this will let you select the individual tiles properly. If your tiles have any spacing in between, sometimes in the tile map you might have that, you can set it to like your per tile spacing, and there will be, if I just make this 10 and 10, you will see that I don't click in between here because it's assuming that, hey, there's going to be 10 pixels between every single tile. In this case, obviously, that's not the case. We have them all connecting up to each other. So it's just going to be 0 and 0, and this lets me select all of the individual tiles. And that really is kind of the only majorly important thing about creating a tile set, aside from adding in collision to all of your tiles. So for any given tile, what you can do is you can add some collision. So for this, for instance, I can just simply add a box up here. You can do that because it's just a box. For tiles like this with a little bit of a rounded corner, it's more or less up to what you prefer. You can just add a box and it'll probably be fine. If you want this to be a little bit more rounded, what you can do instead is do add polygon and manually draw in the collision around your box. This, of course, is a fair bit more work, but if you really care about this rounded corner here, and once you're done drawing, you can just press enter. It will now have a more accurate collision box to this area. For the most part, though, I think just adding in a box is fine. If you want to see which tiles have collision already, you can click on this colliding tiles thing, and that will show you what collision all of your tiles have. So I'm just going to add a box to pretty much like all of these, because effectively all of this needs to have collision. You can select multiple with click and drag at a time, but that does get rid of all of the collision related things. So you do need to add these one at a time, sadly. This is one of those things where you can start seeing that, yes, Unreal does have these 2D tools, but they are maybe a little bit less user-friendly in some cases, and maybe sometimes if you have a programmer on your team that can deal with this, making an extension on this editor which would allow you to do things a little bit more like you would want them to do can be very much beneficial. Whereas in an engine like Unity or maybe even GameMaker or Godot, all this kind of stuff is generally like easily done for you as far as like 2D stuff goes. So for things like these slopes, obviously, that is where I do go in and draw my collision fairly custom, because this does need to just straight up be a triangle. And it's not the most exact science in the world, but you want it to match like fairly closely, I would say. If you notice that you misplaced any of these polygon points, by the way, after you complete the collision itself, make sure to disable grid snapping if it is on, and then just clicking on any of these points, you get a little gizmo to move it back around more into the place that you want it to be. You can do this for entire sides as well. And then for these, I might also do a little bit of extra like geometry for the collision. Nothing too exact and complex, of course, but just something so that it has a little bit more of that rounding going on, to be honest. Because it might feel kind of annoying if you touch up against this little bit of air. Like for these corners that are just 3 pixels big, I'm not really worried about that. For this, which is mostly air, I do think it is probably good to do that, but I'm not going to do that for this entire thing at this point, because I don't even think we're going to be using this tile set in this series. But you can also start with a box, and in cases like this, just like move this down a little bit. And for things like these sides, that's probably good enough. You don't need to go through and make like entire like custom polygons for all those. So now that all these have their collision, at least like very rough collision, we can start using these for an actual tile map. So going back in here, I'm going to go back into my content, and we're actually going to make, before we do anything else, I'm going to make a new level. So we can go into File, New Level, and I'm just going to do this as an empty level. So not an empty open world level, just an empty level. Nothing will be in it, because we don't really need anything to be in it, to be honest with you. So let's save this level as well, immediately as a 2D level. You'll be able to see there's nothing in here, so entirely empty. We'll also make a new Paper 2D tile map. And we'll call this something like level 1. If we open this up, we get this tile map editor. I'm actually going to go into my editor preferences real quick, and I have set that up to be a little bit bigger for the sake of the YouTube video in the scale. I'm going to set that down a little bit more because there's a lot of stuff going on here, so I want it to be a little bit more zoomed out. So in here, we can see what tile set we are using. If you have multiple tile sets, you can switch between them with this icon up here. I only have the one, of course, at the moment. And we can start like selecting tiles and putting them in. It doesn't automatically. This is kind of weird. And one of those things where I'm like, it's not quite a polished system. It doesn't automatically match the size of the tile that you select here. What you need to do is you need to come over into your setup and set your tile width and size to the proper amount, because that is a property of the actual tile map asset, and it doesn't really like take it from the tile set. As you can see, when I make this bigger or smaller, it actually increases or decreases the size of the tile map as a whole, because it is set up to be X amount of tiles wide and high with X amount of pixels per tile. So the tile map width and height, the width you can play around with fairly easily. The height is quite important that you get that right from the start, and I'll show you why in a second. So I'm going to set this to about 32 high, and then let's say that this is 128 wide. So that'll be our level. And the reason that that is important is if we come back in here and we drag this into the level, it's all well and good. It starts at the top leftmost cell. And when I make something taller, so if I go back in here and say, actually, I want this to be, let's draw something in for context's sake. I want this to be 64 high. It adds it to the bottom, not to the top. So that means that your level now has like extra stuff below everything that you've already drawn in, which is, in my opinion, probably not what you usually want. If you're adding extra heights, you probably want to be able to add it to the top. Ideally, it would center out in the middle and you can just expand it to either the top or the bottom or the left or the right. It's just not how it works. It just takes it from the center position of the top leftmost tile, and that'll be the world position of your tile map. It's just kind of how it works. We have to deal with it, unfortunately. I'm going to go back to 32 for this one. So from here, it just kind of works as you would expect a tile map to work. You can select your tiles and then you can like start drawing things in with the normal painter brush, and that works exactly as you would expect. You also have this fill bucket, which of course works to fill out parts of your areas. Do be sure to switch back to painting. They all have shortcuts. We have an eraser under E, fill bucket is G, and the paint tool is B for some reason. Now, there's no system for intelligent tile picking where it just chooses like edge tiles when it's on the edge and these inside tiles when it's on the inside. You have to do that manually. However, what you can do is you can hold Shift and left click drag to kind of make like a stamp that you can easily copy over. Now let's erase these. And now we have like the basics of like this platforming level, right? So that's a little bit of a saving grace, but it's not great. I'll be the first to admit. So let's copy some more of these over. This will just be our level, just jumping from side to side to side to side. And there we go. Now let's add a background next. Well, actually, no. Now these tiles have their own collision. So if we scroll into the details panel to the bottom, we can see the collision thickness. This is how far the collision extends to the left and the right. You might be thinking, what does that matter? Well, this might be 2D, but Unreal's physics system and everything about Unreal Engine still functions in 3D, right? So if we look around, like this is a 2D tile map and it exists, and we have like all the tiles and the sprites that we're using. They are entirely flat. They don't have any width. If we look at them exactly from the side, you effectively can't see them. But it still exists in a 3D world, and your character's still going to have 3D collision. The navigation is still going to be, if you have AI navigation, still all going to be using 3D nav meshes. everything still functions as a 3D game. So this collision needs a little bit of thickness to work on. And a collision thickness of 50 usually is fine. That means that it extends 50 units in either direction. And usually this collision thickness of 50 is fine. If you need a nav mesh for your characters that need to like navigate, the thing is, you probably don't need a nav mesh in most cases if it's entirely 2D. But if you do, you might need to make it a little bit thicker because the Unreal nav mesh volume might not recognize that thin of a collision strip. So setting this in that case to something like 100 might be a little bit better. But for the time being, 50 works. And we effectively like have the start of our level now. Let's add a new layer to this as well, because that's an important part of setting up these levels. Now, the upside of Unreal being a 3D engine primarily is that it does make it very easy to create layered parallaxing, where the background moves at like a different speed to the foreground as you move through the level, because that is just how 3D perspective works. So we can take advantage of that by creating a new layer. Let's make a new layer here and say that it's on the bottom. We have a setting here where we have a separation per layer. By default, that's only set to 4, which is quite small. Let's just make a layer that, let's see, with entirely just this. It's a little ugly, but it'll do for now. If you go back into the level and we look at it from the side, we can see that these layers are, camera speed a little lower please. We can see that these layers are separated by a couple of units. So as I move, you can see maybe that the foreground is moving a little bit at a different speed to the background, because the background is slightly further away. We can increase this separation to something like maybe 25 to make this effect a lot more pronounced. And as you can see now, you can definitely tell that they are moving at different speeds due to the parallaxing effect. And this is automatically added for every layer in your system. So we can add like another layer in between. So this is the entire like far away background. So we can just right click and rename to background. And then maybe we have like an in-between layer where we put down a couple of these like rocks. And that'll be in the middle. And then the background, maybe what we can do is we can like paint some like windows in it. But those are on separate layers. So like the boulder will move at a slightly different speed if we just go like this to the background itself as we move left and right. And then we can even add a like proper background where we can use this blue to just like be a like day sky background or whatever. So now we can just, with the background layer selected, do our like click and drag thing, and now we can fairly easily put these windows in. It doesn't copy over empty spaces, sadly, so you still do need to go through and erase those manually. Or you can just like fill buckets, an empty tile into there, and at that point it will actually copy them over. So that's a nice little trick. If you explicitly make something an empty tile, you can still copy it over. So that's quite like nice to be able to do. And that's the basic idea behind all of these tile map things. So playing with tile maps can be a lot of fun. We still don't really have anything to control our character with. So I think next time we'll set up the basics of actually making a character with 2D controls, and we'll be using the PaperZD plugin for some basic implementation of animation maybe. Now that we have the beginnings of a two-dimensional level, maybe we should have a player character to actually play this level with, right? So that we can see things like the collision working and all that kind of stuff. We already have some sprites set up for the character. So if we go into sprites, we have this little idle animation. And the wonderful thing is, if we just go back into content real quick and we make a blueprint, we can go into all characters, or we can search through all classes, and we can see paper character is a child of the character class. This takes away the skeletal mesh and puts in a paper character that has the possibility for like a flipbook to play on it instead. But since we're using PaperZD on top of Paper2D, which is highly recommended to be able to do. I'm going to do a PaperZD character just because it has an animation component on it as well. And an animation component will allow me to use animation blueprints from PaperZD, which just makes this entire process a little bit smoother to work with. So highly recommended to do. It's entirely possible to hard code a bunch of this stuff within your character itself. PaperZD just makes it a little bit more approachable. So we're going to go for a PaperZD character, and I'll call this the BP player. And opening that up, we can see we have, just as a normal character, we have this collider, and then we have our sprite. We set our source flipbook to the default animation that we just want to see in the viewport. Then the animation component itself will have an animation class assigned to it, which will then influence that as we go. So let's set this to player idle. We can see the size of this thing. Now let's put it roughly into place, and then also maybe change the perspective from perspective to right. That way we can see it without like any weird perspective distortions. And maybe the capsule radius needs to be a little bit bigger for this guy. And let's set the capsule half height to slightly bigger as well. And then we move. Well, the capsule half height actually seemed pretty good. So now we have our 2D character, which doesn't do anything yet, but we can at least assign this to be our player start. So let's real quick make a game mode to set that. So this will be our 2D game mode, where we can set the default pawn class to our BP player. Then in our project settings, we'll just look for game mode, and the default game mode will be our 2D game mode. So now we have everything set up to spawn in our player. So let's do a player start, and we can put that anywhere we want. And you'll be able to see that the time map that we made last time is quite tiny. And that is because they are 16 by 16 pixel sprites. And just as we did with the player character sprite here, we scaled it up by 10 times. We'll actually need to do the same thing here in our tile map. So if we go into our tile map, we can see we have the pixels per unit as well. We've set that to 0.1 before, so let's do the same thing here. That scales it up by 10 times. And as you can see, it is quite big in comparison. Let's go back to the faster camera movement speed. And it might be a little bit too big. This is a matter of experimentation a little bit. I'm going to say that that is definitely slightly too big in this case. If you're making a proper game and you have like a pixel artist, specifically if you're making a pixel art style game, do make sure that these settings match between your tile maps and your characters, because you do want the pixels across your game to be the same size. For this example, I don't really care about that, so I'm just going to set this to like 25, so that's about 4 times the size. But that means that the pixels on my character will be significantly larger than the pixels in the background, which is not exactly what you want. I'm also going to make the separation a little bit wider, so let's set that to 50 instead. So now we should be able to play the game, except that we don't yet have a camera on this thing. So let's add a spring arm component real quick and rotate that around so that it's facing toward your sprites, and maybe move it up a little bit. And then I'm going to give this arm length a length of like 700, something like that, so that it's a little bit further away. Then let's put a camera onto that, which we're just going to zero out the location and rotation for, so that's just at the end of that spring arm. And now when we play as this character, we'll look through this camera. One important thing that you probably want to do is go into your spring arm. Let's call this something like camera boom. But more importantly, we want to go into the camera collision settings and set do collision test to false. Otherwise, the camera might start like punching in when we go past something, and we don't want to have that happen. In 3D games, that's really nice. In 2D games, you generally don't really want that. So if we play the game now, we will spawn in as our character, which can't move around. And you can see, as I said, the pixels on our character are significantly larger than they are on the environment. To the point where I think maybe we actually want to just go into these sprites and just mess around a little bit with their size. So we go into here, property matrix, and we'll set this maybe to 0.2 instead. That does make a change in our actual character though, so now we need to go back in and set our capsule component to something new. So this is the kind of thing that you want to get right early on, because if you want to change this around at a later date, it does become a little bit of a pain to deal with. Because you need to go into like a bunch of different places and then move around a bunch of different stuff, and you just kind of don't want to do that. But we have fixed this now, and let's see where our camera boom is at. It's a little bit high up, so let's make it a little lower down. And maybe we can set this field of view to like 110 as well. So it's a little bit of a wider field of view. And suddenly this looks a little bit better for like the scale of our game, and the pixels are roughly the same size now. Now, if you don't want any parallaxing at all in your game because you want to replicate something that is a lot more retro than maybe a SNES game, maybe you want to do like a classic Game Boy game style, you can change your camera's projection mode from perspective to orthographic, which gets rid altogether of its field of view. And it's effectively everything that it sees is entirely flat. So it's not going to have any parallaxing at all, and everything will just be entirely flat. You can see here the edges of everything line up perfectly because everything is just being rendered as like flat depth. Whereas if I go back into perspective mode, you can see that the edges will be ever so slightly misaligned because of the perspective. Because these pixels are a little further away, so they're a little bit smaller, so they don't fully encompass the entire view here, which can be a little bit annoying to deal with. So maybe sometimes orthographic mode is more what you're looking for. That's entirely up to you and the game you're making. For now though, let's add some character movement input. So we don't have any input actions or anything like that set up yet, because this is an entirely empty project. So what we're going to do is I'm going to make a folder called player, where we're going to put the player character in, and we'll also make a mapping input context. So this will be our input context. We'll get back to that in a moment. And then we'll also make a input action for movements. We'll set the value type for this input action to being a float, because we want to be able to either move left or right, so either to the positive or the negative direction, or stand still altogether. And then we'll also make an input action for jumping, which can remain a bool, because jumping is just either you're jumping or you're not jumping. So then in the input context, we add the mappings for both the jump and the movement. The jump will just map to the spacebar, and the movement we will map to the right key, and we'll add another mapping for the left key. And now the wonderful thing is we need to add in a modifier to the left to negate it, to make it negative. So that way, if we press right, it'll get a value of +1. If we press left, it'll get a value of -1. I have an entire, like, 2 or 3 videos about the input system that you can watch if you need more depth there. But for now, suffice to say that left will be negated. And then you might want to add the same thing for the D and the A key as well, of course. And then the A will, of course, be negated as well. And now back in our player, I have deleted the overlap and event tick, because we don't really need those at the moment. We can just do input action jump, which is going to be fairly easy to do. When we start it, we just jump. That's a pre-made function by Unreal that we can just use. And when it is completed, we stop jumping. So just stop jumping. That's the easy bit. On input action move, that's a little bit more annoying, but you can see that this has a float that it uses instead of a bool. We're going to add movement input with this, and the scale value will be the speed at which we move, so that can be like a variable or whatever. The world direction, we're going to split the structure pin. Usually you get like 2 axes for this, and you do all kinds of weird, like more complicated stuff for a 3D game. For a 2D game, this is fairly easy, because the world direction that we're going to be moving in, we can just go here and see if we select literally any of these actors. The red arrow is the direction that the tile map is going in, so we're moving in the X direction. It's just as easy as that. So we don't need to be moving in the Y or in the Z, we just hook up the action value to our world direction X, and then whenever this is triggered, which will be every frame, because we don't have any like specific custom triggers set up, we add that movement input. Now, these input actions don't work unless we assign the mapping context that we created to our player. So on begin play, we get our controller, which will be a player controller. So we need to cast to player controller because we're going to need to access a function specifically for player controllers. Because we're going to need to get the local player input subsystem or something along those lines. The enhanced input local player subsystem. It's a whole mouthful. You need to get that. Then we want to check just to be sure whether or not that is valid. Because if it's not, we don't want to use it in any way at all. But if it is valid, what we want to do is we want to add a mapping context, and we'll add the mapping context that we just created. And that will allow us to actually use these input actions. So with that, now if we play the game, we can move to the sides and we can jump. We can not jump very high, and the gravity is a little floaty, but that's where we go. Hey, we're using Unreal Engine. We have this character movement component with a bunch of settings that we can tweak. So we can set the gravity scale to be much higher, like 2.5 times as high. Then we can go into here and set the jump Z velocity to something higher, like 1100. And we can even set our air control to be significantly higher. So if we set our air control to being a value of 1, we get more control in the air. And the falling lateral friction is the amount that you slow down in the air if you're not pressing any direction, essentially. So if we set this to a fairly high value, something like 5 or 10, that'll also make our in-air inputs a little bit more like responsive. So now we can see we jump higher, but we also fall down a little bit faster. And this feels a little bit more like what you might expect a platformer to feel like. And there's a bunch of tweaking that you can do to make this feel exactly the way you want to feel like. And if we come up to the player itself, if we select that instead of the character movement component, we have the max jump count. So we can even very easily make a double jump here. So if we set that to 2, we can see that we can jump twice. And all that like platforming goodness, actually like the engine does take care of that for you. And now that we can move around, you can more easily see the parallaxing of the different layers happening. Which again, if you don't want that to happen, you can either set the layer separation to a very tiny amount, or you can set the camera in here to use orthographic projection instead, which will make everything just entirely flat. So everything, like you can see, there's no parallaxing going on anymore at all now. I like the parallaxing though, so we're going to stick with perspective. Now that we have all that set up, the next thing to do is animation, and that's why I picked a PaperZD character and not just a paper character, because we have this animation component that is supplied for us. But I think we're going to do that in the next video, just to keep things segmented a little bit. So thanks for watching. If you want the project files up until this point, or the project files for the finished course as a whole, so where we end up at the very end of this with everything that I show off implemented from start to finish, there's a link down below in the description to the Patreon page, or for YouTube members to download those project files, either a per episode progression or the entire series as a whole. We now have a start to a 2D game, if we wanted to call it that, but this guy is just kind of facing one way and just doing this idle animation over and over and over again, and that's maybe not ideal. So we're going to dive into using PaperZD, which is an external plugin, but it's really, really useful, and I really recommend that you do actually use it if you're going to do 2D development in Unreal Engine. That allows you to set up animation blueprints, much like you would do for your 3D characters, with 2D animations instead. So let's take a look at that. I have my player character here, which is a PaperZD character like we made in the last part. And the reason that I made a PaperZD character is because it comes with this animation component. And an animation component can have an animation instance class. Again, much like we have with animation blueprints. There's a little bit of a difference going on here, though, and that is that we need to make a handful of different assets. The first one is we need to make an animation source. So let's call this a player anims for animation source. And this animation source is effectively just the list of animations that correspond to this player, because we don't have things like skeletal meshes that take care of all that linking for us. Like this mesh maps onto this skeleton, and this skeleton maps onto these animations. So this animation blueprint has access to all those animations. We don't have any of that in place because they're just flipbook animations. You can play whatever you want at any time, right? We need to set up that list of animations that we can access in our animation blueprint ourselves. So we can make animation sequences as well. So PaperZD, you can make an animation sequence, link it to an animation source. Let's call this just the player idle. And if you open up any animation sequence, it'll open it up like this, and you can see the animation data. You can just pick any flipbook that you want. So this will be the player idle. Now I need to extract more sprites to make all the other animations. So give me a moment to do that real quick. We've done this in another video, so I'm gonna skip over all that. But I will be doing that real quick with just extract sprites. And here we have the walk cycle. We also have an attacking animation that I might extract in a moment, but for now let's just do the walk cycle, and then I'll also extract the jumping pose that we have right over here. But just to show you, you can also make an animation sequence just in your animation source asset by going new animation sequence, and then we call this player walk, and we can assign it in the exact same way with just a drop-down menu here, player walk, and there we go. I do need to go through and set the origin point for these to be properly centered at the bottom though. So bottom center. And the pixels per unit should also match at 0.25. So now we can see that if we go back and forth between the two of these, they are aligned exactly the same and they're the same size. So they actually match. If I go in here into like any of these sprites and I set this to like 0.1 instead for all the sprites that I just did, you will be able to see that it physically shows you a different size in this viewport. So it's a really nice way to check if the settings that you set up are actually good. So this is actually supposed to be 0.2, not 0.25. And the wonderful thing that I want to point out here real quick is that if I create a flipbook of only one sprite, so we can call this player jump animation or flipbook, let's call it FB for flipbook. I hope that Facebook doesn't sue me. You can make a flipbook out of just one frame. So if an animation doesn't need to be more than one frame, just do it as one frame. It does need to be an animation in order to work with the animation component though. So you do need to make this into a flipbook, which you can then use in here to make an animation sequence. And we'll call this just player jump to set this up properly. Now I do need to go in here and real quick set these up to be like the proper size and properly aligned. But now you see it just real quick plays the same frame over and over and over and over again, and that technically counts as an animation. So, you know, that's fine. We can finally add in our PaperZD animation blueprint, and that will prompt us to select a animation source. That's the one that we just made. So let's call this player animBP. And this will more or less function the exact same way as a normal animation blueprint because it even has an animation graph with an animation output. So the way that I'm going to do this is we're going to get the paper character, which is a function that we can use, which gets you just the character that owns this animation controller, and that will be a PaperZD character object reference, so we can just easily promote that to a variable and save that out as the character. And from that we can, again, normal animation blueprint stuff, just use this character to get any information out of, do something with that in the tick event, and then use that information in our animation graph. So in this case, what we're going to do is I'll just show you the animation graph stuff first. We can just play animations. So we can play walk, and it will be added as one of these walk play animation nodes. And that'll be just hooked up like that. And that'll always play the walk animation. But we, of course, want to tie that to a couple of things. So what we want to do is we want to get the character movement component, which is all the way down there. And from there, we want to get a couple of things, such as the isFalling value, which tells you whether or not we are falling. That also counts for jumping. It's just, it should be called isGrounded and be working the opposite way. But fair enough, it's called isFalling. I will promote that to a variable and call that falling. And then from that, we'll also get the velocity, which is this yellow node here, this vector, and we'll just promote it to a variable as well. Just call it velocity. For now, that's all that we're going to be doing. So the easiest example here is getting our player walk and blend by bool. And if something is true, it'll play this animation. And if whatever we put in is false, it'll play the other animation. So we're going to check, hey, are we falling? Because that's a thing that we're checking on every frame. And if we are falling, we will play the jump animation. And if we're not falling, we'll play the walking animation. We'll also put in the idle animation with another blend by bool in a moment, but we'll get to that. So now we have set up our very basic animation graph. Again, you can all do this without PaperZD if you want to, just within the character's blueprint. It's just nice being able to do it within like an animation blueprint like this. So going back into our character, in the animation components, we can now select that player animation blueprint, and we'll be able to see that if we play the game, it has the walking animation, and if we jump, it has the jumping animation. So our animation blueprint so far is working. There's two big major issues though. Number one is it's not directional. It doesn't flip around when we walk into the left direction. And number two, and this is maybe more important, is we're standing still and it still has the walk animation. So we need to fix both of those things. And both of those things actually have to do with this velocity that we had in our animation blueprint. So let's actually break the vector here, because we are going to need both of those. And we're going to use the X velocity because we're moving again in the X direction. If we just select this thing, we can see the red arrow is the direction that we're moving in. So that's the X direction. And we will just compare float, which is a really nice little macro that we can use. We're going to be comparing this with 0 because we want to check whether or not it is greater than, equal to, or less than 0. Because if it is equal to 0, we can just make a new variable here and call that idle. If our X is equal to 0, we're idle. We're not moving. If it is not equal to 0, we are not moving. So there we go. You might be wondering, why do we use this macro for this? Because we also are going to use this to flip around the animation sprites, depending on whether or not we're going left or right. PaperZD, for amazing as it is, sadly doesn't have any built-in sprite flipping. So what we're going to do instead is we'll just take our character and invert its scale, which effectively just flips it around. So in this compare floats, we get our character, and since this is already a PaperZD reference, we can very easily just get the sprite from that. You might need to scroll probably down a little bit to get sprite. And we're going to set the relative 3D scale of that sprite. And we'll split this structure pin real quick. And we'll do one of these for greater than and one of these for less than. But we'll start with the greater than. The Y and the Z scale are going to stay at 1. And then the X scale, which is axis that we're mirroring against, will be -1. And then we can just copy this over and make sure to hook up the sprite to the target. And then the X will also just be 1 in this case. So if it is greater than 0, we are moving in the right direction, which means that we mirror the animation. And if it is less than 0, we're moving in the left direction, which means that we play the unmirrored animation. Depending on which direction your characters are facing, this might need to be the other way around. Matter of fact, I think for the example that I am using here, it will need to be the other way around, but we'll figure that out in a moment. Either way, both of them then also hook up to idle being false, because if we're walking, we're not idle. Let's go back into the animation graph real quick, and then this player walk, we'll just copy over the select animation by bool. If we are idle, we will, at false, play the walk animation, and otherwise we play idle. And that will be our basic animation graph for our player for the time being. So we're idle, and if we walk into either direction, first and foremost, the directions are inverted, but there's also the issue that we accidentally, this is my problem, we accidentally put the camera boom as a child of the sprite. We shouldn't do that. The camera boom should be hooked up to the capsule component itself. The sprite should not have the camera hooked up to it directly. Otherwise, when we turn around the sprite, it also turns around the camera, and you don't want to have that happen, of course. So just make sure that, once again, the camera boom is a child of the capsule, not of the sprite. That's just a misclick on my part. And in our specific case, we do need to change around the X scale to when greater than, it is just 1, and when less than, it is -1. And now we can see we can fairly easily move around, and it even works immediately with jumping, because it just inverts the entire sprite. So whatever animations might need to be able to be mirrored will now effectively always happen depending on the direction that you are actually moving in the world. You will see that there's a little bit of an artifact going on when I change around, and that is because there's motion blur. If you're making a 2D, especially pixel art game, you're going to want to do this anyway. Go into your project settings, look for motion blur, and immediately disable it. And now you will see it no longer has that issue. And we have our animated character that can jump around and do stuff. And this is starting to feel and look like a 2D platformer, a very undeveloped bad one. But it is effectively a 2D platformer now. So let's, in the next couple of videos, maybe look into some things that are maybe a little bit more specific to 2D platformers, but will also just be fun and good to develop, and show off a couple of other things about Paper 2D that might be nice to know for you. So now that we effectively have an entire 2D platformer to play along with, there's a couple of things that we are going to have to do when we actually start designing levels. And I want to show you one way of working with that. So what we can do is we can just go into our tile map and start putting down some things like extra platforms. So if we have this type of platform, we can just put a couple of those down. Suddenly we can platform up there. But what if we want this platform to have some kind of behavior? At that point, it would need to be its own actor, right? Because this is just a tile map. You can't assign behavior to specific tiles or anything like that. So as far as these static platforms go, this is entirely fine. We can just use these as static platforms, and for the most part, nothing is really wrong with that. But what if we want these to be able to move, for instance? Well, that is where tile map actors come in. So let's make one of those. We can go into blueprint classes and we can look for tile map actor. Paper tile map actor is what they're called. And let's call this moving platform. And what we can do in here is we have a renderer component where we can assign any tile map that we want. So maybe don't assign the level tile maps here. What we can do instead is we can just make a new tile map for the platform. So platform, select this, and then just set up all the settings properly. So that will be 16 by 16. The height will just be 1, and the width will be 3 tiles wide. And now we have a tile map that is just a platform. And we can pick that for our tile map actor. It doesn't seem to show within here, but if we drag this into the world, we will see that it actually does properly show. Now, we do need to, again, make sure that this is set to properly using the right pixel scaling. So I think that's 0.25 in our case. And now we have this one actor that behaves as an actor that can have code to itself in the game that we can place in the world. It'll also have its own collision, just like any other tile map, any other sprite can. But we can code this to move around. So let's do that real quick. We can add in a start position and an end position. And I like to make those actor references so that I can easily set them up in the editor. So what I do is I make these two exposed, and then I also add in a is moving forward, which will be a bool that doesn't need to be exposed, and then a movement speed. This is all fairly generalized Unreal stuff. This is not just for 2D. This is you can also do this for a 3D platform, obviously. And then in the event tick, what we do is we get the movement speed, we multiply that with the delta seconds, and we set the actor location to the get actor location plus our movement speed multiplied by a direction. So the way that we get that direction is our current actor location and whatever we're moving toward. So we can either toward the start position or the end position. Which one we pick entirely depends on whether or not we're moving forward. So we're going to get an actor location, but which one we'll get from a select node. And we'll select that based on this bool. So if we are moving forward, we will be moving toward the end position, and otherwise we'll be moving toward the start position. And we can use the find look at rotation node from our start to our end, and then turn that into an X vector to get just a normalized direction for that. So we do all of that, which is like quite a lot of nodes here, but that's what you get with Blueprint. We do all of that multiplied, of course, by our direction, and that is what we add to our current actor position. Then we kind of just copy over this whole select node situation, because what we do is we want to check distance to, and then the other actor is, again, depending on what we're moving toward, start position or end position. And if that distance to is, let's say, less than 10 units, we simply flip the is moving forward to its opposite value. So we get is moving forward, a not bool, to get its new value. Now what we can do is we can put this moving platform into the world. Do pay attention to the fact that when you put something in the world, it will likely get put up against the background layer, and you need to manually go back and make sure that it actually aligns with your front layer. So it's nice to just set your tile map to exactly be at y equals 0. So that way, whenever you put something into the world, you can just say y equals 0 and be fairly certain that it just is fine. Now, I can move this thing freely around, which maybe is not what you want. Maybe you want this to be snapped to your grid as well. And that's what I personally like. And this requires you with a little bit of finagling around work. We can make it work. What we'll do here is the very first thing is I will set the location of everything just to 0, 0, 0 for the tile map. Then we need to figure out what the dimensions of one of these squares is. And we have set this to, I believe, 16 by 16. Yes, and then the pixels per unit is 0.25. So that's increased by 4 times. So each one of these squares is 64 by 64 Unreal. So we want to offset the X and the Z by 32 units. And I'll show you why in a moment. And then we want to set a new snapping option for the distances to be 64 units. And the way you do that is you go into your editor preferences, which you can get to through edit and then editor preferences. And you look for the word snapping. There you will get to the level editor viewports. And here in the decimal grid sizes, you can just add a new one. And that will be whatever size you need it to be. So in our case, I think that is 64, if my math is correct. Going back into our 2D level, now if I go here, I can set up 64. And if I just look at this from the right perspective, and I set it to lit mode, you can see that the grid from Unreal actually matches up with the grid from the tile map itself. So now when I drag in an actor, it will snap itself to that grid, but it will still set itself to the backmost layer, which is a little bit of an annoyance. As you can see, it's very far back, but if I set this to Y0 now, it snaps to the grid of the level editor itself, which is quite nice. So now, with that, we have our starting position and our ending position. And for these, we can just kind of use a special kind of empty actor called a target point. Which we can just put anywhere in the world. Again, it snaps itself back to like minus 33,000 for some reason, but we can just copy it over real quick and put another one over here. And from there we can say, hey, your start position will be this target point and your end position will be that target point. And now if we run the game, it doesn't have a speed because the speed is set to 0. That is very funny. Let's set the movement speed as an exposed variable as well and set that to like 200 units or something like that. So that means it'll be moving 200 units per second. So now we can see that we have a platform that moves back and forward. And that's all thanks to the tile map actor allowing us to make a tile map, and as its like rendering component and as its collision component and everything like that. We can even use the tile map actor to, in real time, change what tile map this thing renders as, which can be a little wacky, but can also be fun. And we can add any code we want to any tile map that we need to. So we'll also probably do one for one-directional platforms that we can jump through from the bottom, but stand on when we come on from the top, that kind of stuff. But this is the tile map actor. So this is a very useful and powerful tool to be able to use in your actual like 2D level design. Again, there's a little bit of an issue with some of the 2D level design stuff, because you preferably want all of your actors to just be set to y equals 0 when you drag them in. One way to fix that is just to go to your moving platform construction script and on construct set the actor location to get actor location, and then split both of these structure pins. X goes into X, Z goes into Z, and Y is just going to be forced to 0. That way, whenever I drag in a moving platform, it will actually set itself to Y equals 0. But you need to do that for every single actor. This is not ideal. I don't know if there's a way around this, to be honest with you. This is only really relevant for like dynamic and interactable elements anyway. Most of the other stuff you're going to implement within the tile map itself, where this is not a problem. Now that we have more or less a functioning 2D platformer with even like dynamic stuff, let's just have a little bit of fun creating some other stuff. So I want to create a platform that I can jump through from the bottom, and then when I'm on top of it, it will be solid. So it's a one-way type of platform. That is something that a lot of 2D platforms have, and it's just a fun little experiment to do. We took a look at tile map actors, which are actors that I can put into the game that are rendering and behaving through a tile map. So we make this little tile map here for a platform, which is just these 3 tiles. Of course, we can make this anything that we want. We can make it wider, we can make it taller, we can, whatever we want to do with it, we can do with it. And then we made a tile map actor of that uses that as its rendering component. So if we just get rid of all these pop-ups, you can see the tile map that it uses is that rendering tile map. So let's copy over the moving platform real quick and call this the one-way platform. And we're going to get rid of all of the code in here, because obviously we don't need any of this for a one-way platform. The one-way platform is actually fairly easy to set up. We don't need begin play, we don't need begin overlap, we only need the event tick. And for event tick, what we're going to do is we're going to get player character, or even player pawn if you want to, because technically speaking, this works in more scenarios. So if you aren't using a character, player pawn is technically a better choice to go with. And then we'll get the actor's location from that, and we're going to compare that to the actor location from this platform itself. And here we need to do a little bit of math, because while in the character the player's sprite might be on his feet, the player location is at the center of its capsule component, and that is kind of annoying. The way that works, I personally don't like it, but it's because it scales the capsule size from the center, so the position is calculated from its center. So what we need to do is we need to check what the half height is of this. In this case, let's set that to an EN44, and we need to kind of just remember that. Or alternatively, you can get this dynamically if you expect this to change during gameplay, like if you have a power-up that makes you taller or whatever, like in a Mario game. In that case, you can use the get player character itself, because you can get the capsule component from that. So that's all the way down here, from which we can get the half height, the scaled capsule half height, and that is the actual half height of it in the world. And the reason that we need that is because we want to compare the position of our player's feet to the top of the platform that we have here. If the player's feet are above the platform should be solid. If the player's feet are under the platform should not be solid, at least toward the player. Because if we have characters walking on top of this, we don't want those to fall through either. So there's a couple of weird little like twists that we have to take into account. But we'll get to that when we get to that. For now, we need to get the actor location, and then let's split that structure pin. We don't care about the X and the Y, only about the Z, so only about the height. And we subtract the half height from that to get the feet position of our character. So let's just use the character anyway, since we're using it this way. This is more dynamic, so if we decide to change it, we don't have to like manually go back in here and change it, so that's kind of nice. Then our current actor's location, which is the platform's location, will also split. And here we need to know how big this actor is. We happen to know from previous experience that these tiles are 16 by 16 and we're scaling them up by 4 times. So the tiles themselves are 64 by 64. But the origin location of these actors, if I click on one, is in the middle. So to get the top location, we should get the actor's location plus the half size, again, of any of these squares, which is 32. So what we do is we go back in here, we get the actor's location, Z, and we add to that 32 in this case. We can pretty much hard code that because we're not going to change that around too much. And then we just check, hey, is this actor's Z location at his feet? Is that greater than the top position of this platform? If it is, we're going to need to change some collision settings. And here we need to make a custom collision channel, ideally, to work with. So let's go into our project settings. In our project settings, we go under engine and then we go to collision. And here we can add new object channels. So let's add an object channel. And I need to make this window a little bit bigger. The name for this will be player. The player will have an entire object channel to itself so that we can set specific interactions for things with the player, that it doesn't affect other characters or other pawns in the game. The default response to it will be block. Most things will just block the player by default. But then we need to go into our player character, and in our capsule component, we do need to go in and in its collision settings, right here, we change this from pawn to being custom. And you see that it doesn't actually show up anything to do with the player collision channel that we've just made. So what you might need to do is you might need to restart the engine real quick for that to take effect. So we're going to do that right now. So after we've done that, we can come back in here and now the object type can be set to player. So now the collision for our capsule component will be treated as a player channel. Also do go into your sprite real quick, now that we're here anyway, and we can check the collision for it. It should be set to character mesh. Since we already have the collision from our capsule component, which we also need to use for our character movement and stuff, we don't really need the sprite itself to have any collision, so we're just going to set that to no collision, because the sprite itself can and sometimes will interfere with some other collision settings, and you don't want to have to deal with that. So now in our one-way platform, again, we can set the collision response to a specific channel. And the channel we're going to be changing to is the player. And what do we want to respond to this as? Well, we want to actually select that based on this bool. So if our Z location of our player is greater than the actor's top location, so that is true, we want to set this to block. And if it is false, that means that we're under it, we want to set this to false. And we just do that on every frame. And that's kind of everything there is to it. So now what we can do is we can get our one-way platform and put it like literally anywhere, to be honest. Now you might have a similar issue to me where this results in your player just falling off the stage because for some reason when you change the object type of the capsule, that might affect the player spawn code, because it's trying to find like collision and it's kind of freaking out over the entire thing. So the way to fix that is easily just to not use a player start, preferably, and just use the BP player placement here directly. Make sure that he's placed at 0, 0, and then just look for possess, and then auto possess by player, just player 0. And if we do that, that fixes it, and we can just walk around and everything is as it should be. And we can jump up here and we can jump through and we can stand on. So this platform only works in one direction now. From the bottom to the top, we can jump through, but it is solid from the top the moment we are above it. So that's how to set up a simple one-way platform. So I want to say next time, let's take a look at adding in a little bit of lighting into this thing, right? Because everything is so flatly lit, I think it's good to take a look at how we can maybe do a little bit of lighting work on this entire thing. We are making some great progress with a 2D platformer in Unreal Engine, which is always fun, but you might have noticed that, hey, we don't have any lights set up here, but everything is super brightly lit, and it's kind of weird in a lot of ways. And Unreal Engine is good with lighting, isn't it? So why don't we take any advantage of that? And there's a little bit of a caveat to this. Unlike an engine like Unity, which has specific lights that work within 2D environments and will cast 2D shadows across 2D environments, Unreal doesn't really have anything like that. So we are going to be stuck with lighting that works primarily in 3D. But we can still do stuff with that. First question to answer though is, how is this even visible if we don't have any lighting? And that is because by default, sprites use the unlit sprite material, which means that they are using the emissive output of the material graph. So if we go into that, we can see it has the sprite source, and then it just uses the emissive color and the opacity mask here to make our sprites happen. But that means that it doesn't interact with any lighting information. But luckily, if we go back in here real quick, we also have a masked lit sprite material. And the moment I click on this, everything will go black because I don't actually have any lighting set up here. So let's take a look at that. We also probably want to go into here, into the blueprint itself, in the rendering components, and set this up as being a lit thing as well for every single one of these. And of course, you can very much make your own materials to interact with lighting however you want. So if you want to do something more complex with how it interacts with any sort of graphics input, you very much can do that, and you can do some like really quite cool stuff with it. You still will see that there's a little bit of like light coming off of this, and that is mostly just Unreal's auto exposure system. I personally, for a 2D game, would say you don't really need auto exposure. So we're going to go into auto exposure in the project settings and just disable it. And now everything will have a consistent exposure. It's still a little bit weird because it is actually casting light out of the selection that I have. So that's a little bit weird. And that is entirely due to the fact that we are using Lumen. So the global illumination method, I'm going to set that to none because you probably don't need that for most of your 2D games anyway. Reflection method also none. And now everything is actually fully black. So we don't have any like weird lighting going on. Now we can just start placing lights. So let's place a rectangle light here. We can turn this around about 90 degrees and we can start lighting this stuff up. So we set the source width and height. We maybe even want to do this from the just like the right perspective. You don't see everything properly sometimes, so maybe you need to zoom out a little bit. For this, I don't think you need to line it up very much to the actual pixels. You just want this to be in a place where it'll look good. And then let's set the barn door length a little longer and then make them go in a bit so that we have the idea that the lighting is coming in from the outside here, right? And we can set the intensity and the color just like you can with like effectively any light in Unreal Engine. So from there, it's actually easier to do this in unlit mode. We can very easily just copy this over. You can copy things by holding Alt and dragging them around. So let's start off by putting in these lights around like these windows that I've created as an example. And if we go back to lit mode, you can see now we have like a little bit of lighting going on throughout the level that seems motivated by the fact that there's like these holes to the outside sky. Now we can add some point lights as well if we want to. Do make sure that they are set to maybe not even like 0 Y position. I think you want these to be set a little bit away from it, so a little bit into the positive, so that your character doesn't like run through them. Although you can do a little bit of funny stuff where you put these lights between layers, where it only lights up the background layer and not the foreground layer, for instance. So there is some creativity to be had. By default, these sprite things don't cast shadows, which is very much a good thing in most cases. So let's add in maybe like a little bit of like orange light to warm this area up a little bit and make sure that we can actually see the platforms everywhere. And that is a good start for some actual lighting going on, right? This is by no means a course on lighting in Unreal Engine. For the most part, a lot of these lights, you probably want to keep them on stationary mode. That way they will be able to be baked down onto things that are static, such as the tile map itself is static, that doesn't go anywhere, it doesn't move anywhere. But it will still be dynamic on things like your player. So now if we walk through the game, we can see that the lighting is perfectly like interactable with our player. And if we go into the darkness, we're darker. When we go into here, we're lighter, and so on and so forth. So it's fairly easy to set up this lighting in 2D. That said, casting shadows in 2D is just simply not something that Unreal does, because these lights are just three-dimensional lights. But you can do some fun stuff with maybe like implying some depth by putting some lights in the background like this, and that can just be like funny little stuff, right? And then maybe we can even put like a implied sun, make it like a very blue light. That's maybe a little bit too blue, but it's all cartoonish and stylized, right? That we only see at the very background. It doesn't even like light up the cave wall itself. So there is some creativity to be had still with the lighting. And if you want to just light everything up, you can just literally put in a directional light. And let's go back into perspective mode for this. Let's set this to 0, 0, 0. And we can just rotate this around to just face our level and maybe set the intensity to something a little lower. And now everything just has the same fairly flat lighting, but we can still add some like little touches and whatever. So you don't need to make everything a dark cavern if you don't want it to be. You can very much just make everything lit up with a directional light, but still have the creativity to do whatever you want with. Now, if you really want these things to cast shadows, for instance, maybe the player should cast shadows. That can be desirable. You can just go in here, go into the sprite and scroll down into lighting and enable cast shadows. And now the player will cast shadows. So in theory, if we walk around, we might be able to see some shadows cast by the player, which are at a weird angle, but that's due to the directional light being cast mostly down. If we cast it directly at the player like this, we now get a little bit more of a, it's maybe a little too direct even. So now we see that the player does cast shadows, and it actually does properly cast shadows in 3D. So when they're further away, they're a little bit lighter and in like a slightly different position. And when they're cast on things that are slightly closer to you, everything does show shadow casting properly. We can also cast shadows with the tile map itself. I don't really recommend that because it'll very quickly look fairly ugly. But I'll just show you what that looks like. So cast shadows. Doesn't work as well. I'll be the first to say. But if that is something that you need for whatever you are making, you can enable cast shadows on your tile maps as well. I, again, probably wouldn't. I probably wouldn't even do it on the player in most cases, to be honest with you. So I'm going to disable that again. But that's the basics of lighting in Unreal Engine with like 2D games. It's fairly limited, but go ahead and just experiment. Let's add some physics to our 2D game here in Unreal Engine. Now, Unreal isn't necessarily an engine known for dealing with large-scale physics all the best. It's not horrible at it. But there's definitely engines that deal with large-scale physics better, especially if you do it in 2D, because Unreal does do all your physics calculations in 3D, which on a scaled-up size does start adding up. But we can very much constrain our physics to being on a 2D plane, which means that we can have 2D physics objects, which is quite cool. So, as we've discussed in the past, if I go here and I show the collision of all my 2D objects has depth. This is the depth of the collision of these objects. So they will be able to interface with any other 3D objects or even other like sprites that have thickness to them as well with physics. So let's make a quick physics object. And I'm going to do this fairly easily to start with just a cube. I'm going to set this cube to being on y equals 0. I'm going to set the cast shadow to being false because I think it's ugly. And we're going to just simulate physics. So if I just turn on simulate physics, we will see something happen surely, and that is it falls down, and then when I like jump around and push it around, it just flew off. That's not what we want, is it? No. So what we do instead is let's just open up this details panel a little bit more. In the physics, we can constrain this to look on a certain location and rotation. It also has a couple of modes, which are effectively like presets. We want to lock this on the X and Z plane. So if we do that, you will see that it no longer does any weird stuff. Well, now it's gone. It no longer does any weird stuff in the depth, so it doesn't rotate toward the depth, it doesn't move toward the depth. It now is just a 2D physics object. It only does physics in the same axis that everything else in the game exists. So that is basically how you set up 2D physics for your objects. Now, of course, this is just in a single actor kind of way, but we can set this up in a blueprint class as well. So let's do this as an actor. Let's call this physics. It's very badly misspelled, but sure. Such as this little tree trunk. I kind of like that. So let's make that into a sprite. And we can use some of these things here to edit this a bit, because right now there's a lot of empty space above this and we don't want that. So let's add it to source region. And we can start like pulling this around a little and moving this around a little bit to make this a slightly like tighter fit around it, so that it actually like reflects it. Then we can edit the collision if you want to. And by default, it's just going to be using a box. I don't want to do that. So let's go down here. We have some collision settings. So in the collision geometry type, I'm going to set this to fully custom. Delete the collision shapes, and I'm going to draw my own polygon around it instead, so that it actually will react quite accurately in the world to the shape that it is, because it's going to be a physics object. It needs to be like at least semi-accurate to the way that it is shaped. Not massively so, but like at least something a little like this. We have like one little vert that's in a weird place, but sure. Let's move some of this around a little more, so that it really like lines up properly with the shape. Now, we have this shape in place, so we can go back into our physics actor, where I've added a paper sprite component, which you can just do by going in here and typing sprite, paper sprite, there we go. And that will be our little tree trunk. I think our tree trunk also needs to have a pixels per unit of about 0.2. And then in here, we can effectively just do the same thing. So we select the actor as a whole. So then we can go down, we can simulate the physics, make sure that it's constrained to, in our case, the X and Z plane. And that's kind of all there is to it. So now if I add this to the world, we have a more properly like 2D object, which should be at y equals 0. That will also adhere somewhat to the shape that is actually in. So let's see how that works. There we go. Properly 2D physics object. Now of course, this still does look a little bit on the weird side, the way that it moves around, because it can like rotate around and things that old pixel art games couldn't do with their sprites. So that is a little bit uncanny in my opinion with pixel art. But we have 2D objects that fully have like their 2D physics, which again, it actually is 3D physics. It's just constraining it to the X and Z plane. So if you have like 1,000 of these objects all interacting with each other and stuff like that, it's going to more quickly slow down than an engine that actually does the physics for 2D objects in only 2D. I think we're getting somewhere close to having covered all the important things about Unreal's 2D, but there's one thing that I've skipped over, and that is the fact that much like static meshes or skeletal meshes can have sockets that you can parent things to, so can sprites. Yes, indeed, they can. So let's take a look at the player sprites here. And let's just go into one of them and we can add a socket. And let's call this socket head, so that we can put things onto his head. We can very much just move this around to be on the top of his head. Now we need to do this for every single one of his frames, which can be a little bit annoying, but luckily we can do this with the property matrix as well. So we can just take all of these, asset actions, property matrix, and we can add a socket to all of these called head. So now all of these have the socket named head, which we do need to one by one actually put into place everywhere. So that is slightly annoying. Let's go to player 3. You might notice that if you just use the sprite list here, that doesn't immediately update with having the socket. So you do need to open them up from your content browser and then they'll have them. If you just restart your engine, that also should make it able to be edited from there. But I'm not going to do that because that takes time and I don't want to do that. Now, it doesn't work as smoothly as just adding something as a child here and sending it to this socket. So what you do instead is, like on begin play, what we can do is we can add a paper sprite component through our begin play, and we will attach that component to another component. And there we can give in the socket name for head and make sure that it has the proper capitalization. Did I do it with a capital H or not? I did. It's good. And then the parent will just be like our sprite. And we can set the sprite as well. And the new sprite that we'll be adding will be, let's do this dummy sprite. I don't know how big it'll be. Might be huge, might be very small. I guess we'll see. So now you can see when I have that head socket, it is tied to my head. But when I am in an animation that doesn't have it, it just goes to 0, 0, 0. And that is just because those sprites don't have that socket yet. But with that, especially if you're using like a little bit of depth, if you like offset it by 1 pixel, you can maybe make a customized like clothing system for your 2D characters, or like even show the proper armor that they're wearing in your game if you're making like a 2D RPG or whatever. Because sockets are very much a thing that you can use on your 2D characters. Once again, the project files for the entire course, every individual episode, as well as this finished project, will be up on both Patreon and for YouTube members to download if you want to get your hands on the project files. There's also links down below in the description for free to these assets that I've been using because I didn't make these. These are just assets from the internet that I found on Open Game Art. So go show some love to the people who made the actual assets that I've been using as well. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. And of course, an extra massive thank you to my Cave Digger tier supporters, Sir J. Thomas, and my Cave Student tier supporters, Oiku.